Okay, let's start. What I want to do today is control my NeoVim with my racing wheel. Let me show you the Logitech G923 racing wheel. So this is the wheel. I have a wheel with bunch of buttons and some pedals for acceleration, brake, and clutch. What I want to do is whenever I'm moving the wheel, rotating it to the right or to the left, I want to change the character under the cursor in NeoVim. So for example, I'm rotating it to the right. I want to increase the character. For example, if it's A, I'm going to turn it to B. And when I'm rotating it to the left, I'm going to decrease the character. So for B, it will become A. That's what I have in mind right now, but as we build the project, we're gonna map the rest of the buttons. I'm thinking maybe I'm gonna use the shifters, for example, the right shifter under the wheel. When I hit it, I'm gonna go into the insert mode. When I hit the left shifter, I'm gonna go into normal mode. So stuff like that, but essentially that's the project. We're gonna figure out the rest as we build it. And I'm gonna write this project in Go. I just started learning Go, and it's a pretty simple language to learn. In terms of syntax, it's pretty small. I think you can learn it in a day or two, but I believe in order to really understand a language, you need to build a project with it. So I'm going to use Golang, and to really learn it and learn how input events work and stuff like that, I'm not going to use any libraries. I'm just going to read the raw inputs, encode it in binary format. We are going to decode it, try to parse the messages, understand what the wheel is sending us, and then set up a Unix domain socket uh, messaging between my NeoVim process and the Go process and send messages between each other and handle them. So let's just get started. I'm gonna open my terminal. Let me zoom in a bit. So first of all, let's go to the projects and create a new directory, call it wheel D, short for wheel daemon. Let's go to that directory and initiate a new Go project, call it wheel-d. All right, everything is set up. And what do we need to do now? So how are we going to listen to events? In Linux, we can ls the files in dev input that start with event, and we can see a bunch of events. To understand what type of events these are, what devices are sending these events, we can read the file in sys class input, the name of the event, then device/name. So for example, for event 4, the device that's sending these events is the PC speaker device. We can check for other events. For example, in 27, I have a gaming keyboard. So what we need to do is go through these events, search for the name of the device sending this event, and try to find our Logitech racing wheel. Right now, I think it is event 256. Yeah, we have Logitech G923 racing wheel that's sending this event, but it may change when you switch ports or stuff like that. So we need to go through the events and find the Logitech device. So let's start. I actually doing that. I'm gonna create a new file, main.go, package main, func main, print line, chat. Is this real? Let's see if this works. Go run. Package, what? Package, oh, I didn't save it. Go run, chat, is this real? Okay, so we have this working. All right, so let's start by listing the events. What we are going to do is create a new variable called devices, and it's gonna be file path glob dev input event star. So we're gonna grab all the events. If there is an error, I'm gonna print line unable to list events, and we need to exit the process with exit code 1. Okay. So now that we have the devices, let's actually check if there are any devices. If not, we're gonna print an error message unable to, or actually no devices found, and again exit with exit code 1. So now that we have the devices, we need to go through each device, and as we did previously, let me make it bigger, we are going to read this file that's gonna send us the name of the device. So it's in sys class input the name of the event, then device name. All right, so for each device, range devices, I'm gonna get device name path, which is fmts printf sys class input, then we're gonna interpolate the string here, device slash name, and the string is going to be device. So essentially we are going through all of the events and getting the device name paths. Now we need to read this file. So os read file device name path is gonna return slice of bytes and an error. Let's call it name bytes and error. And if we have an error, we're gonna print an error message. Let's say unable to read device name. Let's also give it the device for event, and it's gonna be the event name. And we need to exit again with status code 1. Okay, actually we are not going to exit, I think, because we may have a issue with one of the events, but that event may not be our Logitech device. So let's just print this, and instead of exiting, let's just continue the loop. All right. Next, I'm gonna turn this into a string, so name bytes into a string. Now I have the name. Let's first of all, let's print the name. Name is name. All right. Let's run this. Okay, unable to read the device. Let's actually input for dev input. Yeah. The issue is we are sending the full device path. Instead, we just need to send the event part of it. So for that, we need to do file path base. So we get the last part, that is the event plus the number, then try to read it. If I do this right now, we can see all of the devices that are sending events. And we can see we have here Logitech G923 racing wheel, so on and so on. So we can try to find it. So for each device, we grab the name and we check if strings index name Logitech G923 not equals -1, which means the name includes the string Logitech G923. Let's print this, see if it works. Found name. Okay, let's run this and we are good to go. So the next part, what we need to do is reading the events, not from So this is how we read the device name, but if we want to actually read the events from the input, we need to go back to the dev input event and start reading the file. So it's right now reading, and if I move the wheel, you can see a bunch of binary data coming in. So we need to open this file, start reading, and decode the binary message into something readable, something that we can work on, and then move forward from there. So what we need to do is start reading this file. But right now, instead of doing all of this in main, I'm just gonna go and uh, copy this, create a new package input, and I'm just gonna call it input.go. And in main, I'm gonna remove all of this and go to, oh, it didn't save. Okay, let's just move everything here, name it package input, and here I'm just gonna remove all of this from here. So okay, we have a package input, and instead of main, I'm gonna call it init. So whenever this package is initialized, we're gonna do all of this. And let's create a device path string, and when we find it, we're gonna assign that event to the device path. All right. What do I think about the gain factor of ligature fonts? I don't know. I think Twitch on its own. I don't know. I like ligature fonts. If that makes you gay, then I'm all for it. I love them. I think you should use ligature fonts in NeoVim. And I think you should have a GPU accelerated terminal. I'm using Kitty, probably the best terminal out there. And I'm on Void Linux, by the way. Let me neo fetch real quick. I'm on Void Linux. Let's make it bigger so you can see my graphics card. I also have a 4070 Super running. And fun fact, I'm using Hyperland. There are a bunch of cool stuff. I have a Olama server running locally. I have a Mistral model deployed locally, so I can ask stuff like how to read a file in Golang. And it's gonna do its thing and give me the code, stuff like that. So it's all running locally. I think it's pretty cool. All right, so we have this input package. We initialize we declare a variable device path that's a string, and we go through the events, find the Logitech G923 device that's sending the events, and we are saving the path in this variable. And this is going to do in the init function. So whenever the module is initialized, we're going to do this once, assign it to device path, and move on. Next, I'm going to create a function called listen to events. What we are going to do here, first of all, let's func so that I'm gonna add some comments so that the linter doesn't scream at me. Input package, I think package input is responsible for listening to input events and parsing them. All right. Okay, everything is fine. So right now we need to open that file and start listening to events. So to do that, I'm just going to do os read file, device path, if error, fmt print line unable to read the file device path and OS exit 1. What's the issue? Oh, not equals nil. Okay. Invalid file not equals nil. Okay. And we are going to defer f dot close undefined type. Oh, instead of read file, I need to open the file. Then we are going to read it. All right. So right now we need to listen to events, but to understand what kind of data we have, let's go through Linux input event encoding. Let's try to find the path, the Linux documentation. Input. Okay, let's go through introduction. I just need the interface. Okay, let's event interface. Okay, so the input event. So it's a binary data. We have time val at first. So if I'm not mistaken, the time val is unsigned integer 64-bit. Two of them actually. One is sec, one is usec, but we are not going to use it. So I'm just gonna, let's just put this here, zoom in a bit. Okay, let's start by defining this event type that we are going to decode. So type event, it's a struct. I'm just gonna get rid of this time value because I'm not gonna use it. I think I just need the event type, the event code, and the value that's being sent. So for short, I think it's uint 16. So I'm just gonna go type uint 16 type. Same for code. Oh, sorry. Type and code, they are both uint 16. Let's give it a event struct. Let's give it a comment so it doesn't yell at us. Then we have value. So the value is int. So it's uint 32. All right. So now we have our event struct, and so we open the file. We have the event type. Let me close this. What do we need to do? Let's first initialize a new empty event, and we need to create a new buffer so we can start reading the events. So I'm just gonna make a byte slice, and the size of this buffer is going to be integer unsafe size of unsafe size of size of event. Okay, we are going to create a slice of bytes with the event size, and start listening to events. Okay, let's print listening to events. And we're gonna create a loop without any conditions. We are going to keep reading for events. So let's just read this into the buffer, read full, reading the file into the buffer. If error is not nil, so there are two options. First of all, if the error is end of file. In this case, this is fine. We can just break from the loop. If not, let's just print some error message, error reading the event. Oh, let's actually do it printf so we can see the actual value of the error. All right. Now what we need to do is in this for loop, oh, if we have error, let's also continue. So we go to the next chunk, next event from this file. So for, as I said, we are skipping time value from the event, And in this event, the time value is, the type time val is uint 64 times 2 because there is sec, let's say time sec and time usec, both uint 64. So if I want to skip that, I need to start reading from buffer 16, right? So 8 bytes in each uint 64 values, so 16 bytes we are going to skip. So from 16, let's just comment it here for now. The next we need to read is type. So event type, we need to decode it, and these are encoded in little endian format. So little endian uint 16 buffer from 16 to 18. So we are reading 2 bytes. We are going to do the same for code from 18 to 20. And the next we need to read the value. Little endian uint 32 buffer from 20 to 24. So we're going to read 4 bytes. That's uint 32. So now we have the event type, event code, and event value. Let's actually go through event codes. Linux input event codes. Event codes. All right. So we have a bunch of them. We have event scene used as markers to separate events. So events may be separated by markers that are in event scene enums. So let's first of all create those enums. We're gonna create, let's do it here, const event scene. Let's do it like this. So 0, we have key is 1, we have relative. So key is just like buttons. Relative is some relative axis value changes. I assume like D-pad or changing the acceleration, stuff like that. And we have also absolute value changes, event abs 3. I think this should be fine because all, all we have is button events and some relative events for wheel rotation or acceleration, pedal press, stuff like that. So we have the event setup here. Let's move this here. First of all, let's print this. Printf. I'm gonna also do a new line here. So printf event is plus v event. All right. Let's just a sec. No. All right, let's continue. So we are going to print the event. Let's insert a new line here and run the program. Nothing happened because we moved it to a separate package, package main for running the input stuff. All right, whatever. And we are going to do input listen events. And that's, I think, that should be it. Unable to read the file. All right, let's go. Unable to read the file. OS open device path. What can be the issue here? Just a sec. Let's see what the device path is. We have device path. Now let's add a comment here. Event codes. All right, okay. Let's add a check here to see if device path is not found. If device path is an empty string, fmt print line, unable to find the device, os exit 1. And if everything is all right, let's print racing wheel is at device path. All right. Found, but all right. So we can see that device is found. Something happened in Twitch, but I have no idea how this works. Someone followed. Thank you. All right, we found the name. And what else? We found, but device path. Oh, because I'm assigning it to device name path instead of device path, I think. Okay, found. But we have an issue again. Device path. We are assigning it to name. Device path. Okay, let's remove this. Racing wheel is at, we have device path. Unable to read file. Unable to read file. Read the file. So OS open device path. But the path was the name. Yeah, I think I know what's going on. File path base device. Instead of name, I should instead do device, I believe, because the name was the event with the identifier instead of the whole path. So I think it should now be able to read. Okay, it is reading, but it says error reading the event, invalid argument. Okay. Error reading the event. Read full. Read full. F and buffer. F is a file. Oh, I think the issue is the size of the buffer, because I wanted to skip the time value, but I'm checking the size of this event struct, which isn't equal to the actual event struct because the time here is missing. So let's just add this here. I'm gonna create a new type called timeVal struct. We have seg, which is uint64, and we have usec. All right, timeVal struct. So we are not doing that, but let's not assign it either. And let's hope this does the trick. Okay, we are listening to events. So I have my racing wheel right here. It may not show in the camera, but I'm gonna show it later. So right now I'm turning the wheel and we can see all the events we are receiving. So time, we didn't set the time, it's all right. Type is 0, code is 0, value is 0. So the 0 is sync events. So these are the markers, the separators. So first of all, let's check if event type is if event sync continue. I think it should do, yeah. So now we don't get any type 0. We are just detecting the markers and moving forward. LVim, yeah, LVim is LunarVim. I'm using LunarVim with a couple of modifications. I'm gonna go through that when we go to the part when I write a Lua script to handle the events from this wheel daemon and edit my NeoVim. We are going to go through that, but it's I don't have anything added to that, just a couple of key bindings and the color scheme, and that's pretty much it. I'm not sure if it's going to be today, most probably not. I'm hoping to finish this Go project today so we can read the messages, parse them, and maybe set up a Unix domain socket to send a message and test that message and everything is all right. I'm gonna stop streaming and maybe tomorrow start writing the Lua part to control NVim. Okay, so we get the events. Right now I am moving my racing wheel and we are receiving events. So let me just move it to all the way to the right so we can get the maximum value. So it's 65,535, and if I move it to all the way to the left is 0. So okay, we have the range. We are going to use that. So a type is 3. Let's see what let me just close this. Type is 3. So the event type is relative. Let me just open it here so it's easier. So type is 3 when I'm moving the wheel. When I'm let me clear this, run it. Now I'm hitting the acceleration pedal. Type is also 3. Okay, brake, clutch. So all of them are type 3. I'm gonna press the D-pad on the wheel. It's also type 3. Oh, we have a couple of type 4 and type 1s. What's type 4? We need to check that. All right, so we have type 4 and type 1. I think type 1 is just a button. Yeah, and type 4. Let's again go to the docs. Input event codes. Type 4 on used to describe miscellaneous input data that do not fit into other types. Oh, okay. But I think, so let me just run it again. So I'm hitting a button, X. We got a bunch of events, so I'm holding it. So we got both type 1 and type 4. And type 1 is the button press event type. the value is 1 as I'm pressing it right now. When I release it, I get another type 1 which value 0 and type 4. So I think we can just ignore type 4 right now because we got all the data we need here. So on the button press, the event type is 1 and the value is either 1 or 0. And 1 is pressed, 0 is released. That I think that's all that we need for now. Okay, let's close this. All right, so we have the events. We have the event type set up. Let's leave this here for logging. Let's just go ahead and switch on the event type. So case event, what was it called? Event key. This is our button press. Let's just print something. Let's remove this. FMT, print line. Let's actually do print F, add a new line. Button press. Button press, we are going to do D and okay, D again. Button press. First, we are going to do event, log event code and event value. Next, we are going to check for event apps. Oh, I'm just going to rename this real quick. Apps. Copy this. Button press. Axis change, event code and event value. All right, let's run this again. Okay, listening to events, I'm changing the axis. Okay, code is 0, value is some value. Oh, this is our acceleration pedal and clutch, brake, so all of them. So I noticed this change when playing some games that I had to invert the pedals, the axis of the pedals, because by default is 255, the maximum value. But as you press is, as you can see, it goes down. So fully pressed is 0. So I need to keep that in mind. I'm just gonna press all of the other buttons, see if everything is covered and we don't have any. So button press, we don't have any missing stuff. All right, so I think everything works. But yeah, just to be sure, I'm just gonna add a default case here and print unknown event. And instead of this, I'm gonna log the full event here. All right, so what are we not using? Event rel is not used. So we need the separator, the key, and axis change event codes. Okay, that's pretty much it. Now what I want to do is let's actually create separate files for button press changes and axis changes. So I'm gonna add a new file called button.go package input. Let's open it again. Okay. So I think I need to let's first of all create a function called handle button message, and we are going to get the event. I think let's just get the event. So as you saw, let me just run it again so we can see. When I'm pressing a button, Oh, we get unknown event because of the miscellaneous event type. Let's fix that real quick. Input go if event or event type. What was it? I think 4 event MSC 4 event type is event MSC. Continue. Let's run that again. Oops. Let's run it. Okay, so now we don't get the miscellaneous events. So when I'm pressing a button, first of all, it is 1 as it is pressed, and when I release it, it becomes 0. So I need to only act when the button is clicked. So both pressed and released. Because I don't really care about holding the button for this project. I don't see any use case. Maybe when we find it, we can add it. But first of all, I just want to add ability to understand whether the button is clicked or not. All right, to do that, I want to keep a reference to the previous event. So let's declare a variable previous button event, which is a pointer to the event type. And whenever we are receiving a new event, first of all, if previous button event isn't nil, so it's not nil, and the type is the same as event type, and previous button event code is the same as event code, and previous button value is previous button is 1, so it was pressed, and the current is 0, right? If it is, then let's just print line pressed. Oh, sorry, clicked. That was the whole point. Should have a comment. Okay, handle button message func. And on each call to the handle button message, we are going to assign event, right? Oops, right event to the previous button. All right. So now when you have a button click, I just want to call handle button message function, passing the event. Let's check, go run. I'm pressing a button. I haven't released it yet, so it doesn't print anything. And when I release it, I have clicked. Amazing. All right. For the wheel, for axis changes, I think it's gonna be a bit more difficult. So let's just create a new file, call it axis.go. Let's remove all of that. What are we going to do? Again, let's add a handler message, handle axis message. We are going to get a event, right? And so depending on the type of axis event, we need to do different things. As you saw, let me just run it again. Oops. Prevent button. What was the issue? Okay. So as I'm rotating my wheel, I can see the values are from 0 to 65,000 something. And that's actually 900 degrees. This specific wheel supports 900 degrees rotations. So we're gonna parse that. But let's clear this, run it again. When I'm using my acceleration pedal, it goes from 255 to 0. Same for brake and same for clutch. So we're gonna first of all create some sort of enum, a list of constants that we are gonna use as types, right? Okay, let's so we need that mapping, but let's create okay, let's create the constants. So what type of axis events do we have? We have axis wheel. Let's do iota. We have axis brake, axis clutch, axis accelerate. All right. We also have some D-pad stuff. So let's okay, let's add it, but we are not going to use it for now. D-pad vertical and D-pad horizontal. Okay, now we need to create the mapping. To create the mapping, we are going to run the project again, do all these changes and see what's the event.code and insert it here. So let's first of all create axis mapping map. What kind of data? So it's gonna be event.code. Event.code I think is 64, right? Yeah, uint 64. So uint sorry, 16. And the other is going to be these constants. And I think they are just bytes. Okay, let's just try it. I'm gonna open a new terminal here, go to projects, wheel D, run it and start moving. So this is the wheel. Event code is 0. So for 0 we have axis wheel. Next is brake. Brake is 5. So 5 axis brake. Oops. Clutch. Clutch is 1. Axis clutch. Accelerate is 2. Axis accelerate. DP vertical. Oh, let me find it. DP vertical is 17. 17 is axis D-pad vertical. And for horizontal, D-pad is 16. 16 axis D-pad horizontal. Nice. Let's add a comment. Axis axis event codes, whatever. Handle axis message. All right, func. Okay, let's close this. So we need to parse the value of the event, right? So let's create a new type. Let's name it a new strike. I'm gonna call it axis event, right? Axis event. It's gonna be a struct. I'm gonna give it a type, which is this constant here. So it's gonna be a byte, and we're gonna give it the raw value. I'm calling it a raw value because after this I'm gonna implement the parser. So for raw value, it's gonna be uint 32 because we're just gonna pass the event value, right? Uint 32, and that's I think it. Okay, I think it's fine for now. So axis event struct. Let's add a function on axis event. Axis event. We are going to call it parsed value. Okay. So to parse the value, first of all, let's handle the case for the wheel. What do we have here? We have axis type. which can be access build for condition. Let's say access build. Okay, we are handling access build here. Let's run it again to remember what was the range of the values. Go run. So I'm rotating it to the left. So from 0 to 65, 535. All right, so 0 should be 0 degrees and 65, 535 should be 900 degrees. So I'm gonna, what do we need to do? We need to access the raw value, which is uint 32 over 65, 535 times 900, right? Return. And what do we return here? We return uint 32. Okay, default return 0. Well, oh, export it. Okay, we should add a comment. Parsed value func. Right? Oh, uint. All right. So raw value over 65. 535, that's the maximum. So if it is the maximum, we're gonna have 1 times 900. So that's 900 degrees. And if it's 0, we'll have 0. Okay, so that's the wheel, parsing the wheel value. Let's go for axis. What was the first one? Break. Let's go axis break. So it's from 255 to 0. So we are going to return. I actually want to reverse it. So let's do absolute value of, I think apps accepts float 64. So 255 minus raw value, right? What's the issue? Oh, we need to turn it back to uint 32. All right. We're gonna do the same here for axis clutch and axis accelerate. Okay, and for default, let's just return the raw value. We're gonna handle the what's called D-pad, horizontal and vertical, separately. All right, let's close this one. So we, whenever we are receiving an event, we need to create a new access event, and let's just call the parsed value method, see what happens. So I'm gonna create a new access event. It's gonna be access event. We have access type, so we're gonna go through our mapping and look based on the event code. So if you remember, each event code is mapped to a constant here. So we get the mapping. And what was the other one? I think raw value. So e dot value should be our event. So fmt print line parsed axis value is parsed value. All right, let's give it a try. Let's actually call it first before trying. So handle access message passing an event, and let's run it. All right, I'm rotating the wheel, so it's 900. Oh, so it's 0 if it's not 900. I made an oopsie daisy. Raw value, raw value over, this is uint 32, right? No, it's always 0. Let's just log it here, see what happens. print line row value. Oops. So we get the value. Maybe I should just do this. Float. Oops. Float 64 from the row value times here. And let's turn it back to unit 32, right? Let's check it again. Okay, okay. We have it working now. So at the end we have 900. So we basically turned it to degrees from 0 to 900. That's pretty nice. Oh, let's also check the rest. So I'm doing accelerate, goes to 255, and when it's not pressed, it's 0. Nice. That's cool. What is 65? 535. So I just okay, I'm printing it here so we can check. Let me comment this out so we can see. Oh, equals. All right. Oops. So I just moved the wheel. It's not working. Sorry. Let's do this. Okay. I just moved the wheel all the way to the right. And I noticed the maximum value is 65,535. Pretty sure it's like, I don't know what this number represents, but I know the wheel is 900 degrees. It supports 900 degrees of rotation. So at the end, it's this number, and if I move it all the way to the left, it's 0. So I just took that as a range and turned it into degrees. I'm not sure what that number is, though. It for sure has a meaning. All right, so we did axis events for the wheel, the brake, clutch, and the accelerate. What else do we need to do? I think one thing that we can tackle right now is that we don't have any sort of throttling. I'm just reading and sending events, as they appear. So I may send the same message a lot of times. So let's just add some sort of configuration. And also since we are going to use a Unix domain socket to communicate with NeoVim, the process of NeoVim. I also need to run this input event handlers in a separate Go routine. So let's just add that so we can pass a channel and communicate with this input handler via channel messages. To do that, I need to think of the type of the message that we are going to send. I actually think it's not going to be anything other than a byte at the end, because I'm just gonna assign each event to a byte, then read it in NeoVim and act on that byte. So for example, I'm gonna send 1 for moving it to the right, and or no, I don't know, 2 for moving it to the left. So all I need is to just go create a new Go routine, start listening to events, and with some configurable threshold, start sending me the bytes through a channel. Then in the main Go routine, I'm gonna read this channel, get the bytes, and send that through a Unix domain socket. So that's what I think is going to happen. And to enable that, in the function where we listen events, that's the, let's open the main Go file. I want to do this, Go listen to events, and I need to pass a channel that's gonna receive some bytes. All right. So yeah, listen to events. We're gonna accept a channel. It's gonna be send only, right? Send only channel of type byte. We are just gonna send bytes here. And when we are done, I'm just gonna do this func. Call it, okay. So not only we are going to close the file, but we are also going to close the given channel. All right. So these handle button message, handle axis message, these type of message handlers are going to send me bytes. They are essentially going to return bytes if needed. So let's modify that to send a byte. Let's return 0 for a button message, and for axis message, let's do something and return 1. This returns a byte, right? Let's create a channel, but I want some sort of configuration. So in input, I want to create a configurable channel, but maybe we'll do it as we need it. First of all, let's just test this. So I'm gonna create a new channel, make channel. Just a second, make channel byte, right? And I'm gonna pass it. Oops. I'm gonna pass the channel to the listen to events function. Okay. Then we need to keep listening to messages. So I'm just gonna create an infinite loop here, and we are going to select message. Oops, message is some message from the channel, and when I receive a message, what's happening? Let's fmt print line got message, message. All right. Let's give it a go. So that's the range. Yeah. That's the range of the wheel axis. Go run that. Oh, I'm not sending the events. That makes sense. So I get the event. I say new byte is whatever, and I'm going to send the new byte to the channel, right? I may even do this var new byte new byte equals whatever, new byte. Let's do 3 for now, whatever. And when we are done, I'm going to send the new byte to the channel. Let's actually remove unnecessary logging. Let's see what we have here. Listening to events, handle button message, print clicked. I don't want. Okay, let this fine. On axis, I don't want to do that. Let's do this so it doesn't yell at us, and let's run it. Go run. Got message 1. This is an access event. And if I'm clicking a button, 0. And that's Great. So let's go over what we did here, because I think I'm gonna wrap this up for now, and I'm gonna go over what we are going to do next. So first of all, what we wanted to do, I want to create a project where I can listen to input events from the Linux kernel. Uh, the events that I'm going to read are from my Logitech G9 23 racing wheel, and I want to parse the events and decode them and send a message through a Unix domain socket through my NeoVim process, where my Lua plugin can pick up those messages and do some events on NeoVim. Essentially, I can just move my racing wheel and thus control NeoVim. Eventually, when I'm done this project, I want to create a bug, some sort of race condition bug in NeoVim, and use my racing wheel to solve the race condition bug. I think that's hilarious, and it's a nice project to do. I actually wanted to not use any dependencies to understand it better. I'm also learning Golang and doing this project as some sort of a toy project to learn the language. So how we are doing all of that? Let's go through the init function of the input package. First of all, I am reading the events. Let's open a terminal here so we can see we can see each step from this program. So I'm getting the list of all the events. Then I'm grabbing the last part, this event plus some number identifier, and I am reading the file in sys class input, the name of the event, then device name, and I get the name of the device that's sending the event. I look through all the devices, find the one that includes Logitech G923 in it, and I realize that the device is found. I assign it to the device path variable, and that's it. If any of these steps didn't succeed, I print some error message and exit the process with source code 1. Next, we need to listen to the events. We went through the Linux input events, and let me just open it up. Let's go to the event interface, if I can find it. Event interface, here we go. So this is the event type. This is going to be encoded in binary and be written to that file that we are going to read. So it is consisted of time value, type, code, and value. Time value is some sort of like a timestamp when the event was triggered. We don't really use it in this project, so we are just going to ignore it. Then we have unsigned short for type, unsigned short for code, and unsigned int for value. I replicated this event struct in Go, so you can see time is time val, unsigned integer of 64 bits, and for second useg. That's the time val structure. Then we have type, code, and value, with each of its corresponding type from the Linux kernel events. For event codes, we went through the available event codes. We see here we have event scene. This is event, as it's a separator event that we can use to understand that the input is ended. So we can move forward to the next one. We have event key, event apps, and event MSC. Event apps is axis change value. So for example, I'm rotating my wheel, I will get a new event of type event apps, and event MSC is some sort of miscellaneous events that do not fall in any of this category. I just use it for sort of handling unknown events, but so far we've been good by just using event key and event apps as our types of events. So we have the event structure, we had the event types. Now we need to parse it. So we are opening the file, the same file that I showed earlier when we showed the event plus number identifier. We found our Logitech device. We know the path to which the device is writing events. So we can start reading the file and go through the events and parse them. We do that in listen to events function. We open the file. If there are any errors, we handle them. We create a new event. We get the size of that event because we are replicating the exact same structure from the Linux kernel docs. We can take the size of this event. Where was I? We can take the type of this event. Sorry, take the size of this event and assign it as a size of a buffer to which we are going to read from the device path. In this way, when we are opening the file, we are reading it to a buffer. And since we are replicating the exact same structure from the Linux kernel docs, we know that that buffer is going to include the full information from the event. So if we do that and we have our encoded data in the buffer. To decode it, we again look at the docs. We know the structure of each of these values. Okay, I get some sort of spam message for the first time. Okay. So we get the event from the buffer. And as I said before, I don't really care about the time step, so I'm just going to ignore it. So I'm going to start reading from the 16 byte. So first 2 bytes are the event type. That's unsigned integer of 16 bits. It's encoded in little endian format, so we decode it, assign it to type. We move 2 bytes forward, then decode it, assign it to code, and we read the next 4 bytes and assign it to value. That's it. Now we have the event object. We have the decoded event, and we can act on them. The buffer idea is really great. Thank you. Actually, let me okay, I'm gonna say it now. I got that idea from code crafters. I think it's the best way to learn a new language or just keep your knowledge fresh. And it's pretty nice because they have different types of challenges, right? Build your own Git, build your own interpreter, or build your own HTTP server, and stuff like that. Stuff like we use every day. Which code crafters course did you take? Do you pay for it? I do pay for it. I don't know if my subscription ended, but I think it's worth it. It's an amazing service, and I gained a lot of confidence just doing some very simple, like build your own HTTP server. And uh, the ideas that I learned from there, I'm using it here. I think I did the exact same thing uh, for build your own DNS when I was parsing DNS messages. The idea is basically the same, and it's all over the place. So I think code crafters give you the opportunity to learn some very basic stuff that we take for granted, and you can apply it anywhere else. Even if you don't apply it, you will know how things work, and it will make you a better engineer, I believe. What lengths did you use to build the projects? I haven't used Go yet. This is my first ever project in Go. This is my first time writing like real Go. In Codecrafters, I think I did build your own DNS and build your own HTTP. I did both of them in JavaScript. I think I did one in JavaScript, one in TypeScript. So I'm happy I have only 6 viewers, so you can't all roast me. but it was fine. I got the knowledge and I'm trying to apply it somewhere else. That's it. So we have the event, we have the decoded event, and we read that the event scene is for separating different events. And we had also some miscellaneous events. I'm just ignoring them for now. So if the event is either a separator or a miscellaneous event, I just continue the loop. If it's not, then I need to check the event type. If it's a event key, which is the same as button press and button release, I handle a button message. If it's a relative axis change, actually absolute axis change, I use handle axis message. If it's not, I just let the user know that it's an unknown event and move forward. For handle button message, in this function, I need to do something extra because with this type of events, I get button press and button release, but I don't really care for it. I'm not going to use it in any way. I just need to know if the button is clicked. So I store like references to the previous event, and for each event I check if we have the exact same event, exact same button was pressed or it was released. So I check the type and check the code. If it's the same, I check if the previous value was 1 and the most recent one is 0, which means previously it was pressed and now it's released. That means I have clicked event. We don't handle it here yet. That's for the future, but that's the main goal here. For access messages, I created a new struct called access event. Here I hold the type of the access event and raw value. I also have a method called parsed value, which we are going to go over in a second. So access type, I separated all the access buttons or access inputs on my racing wheel. Those are the wheel, brake, clutch, accelerate, and I have a D-pad that sends separate events for vertical or horizontal changes. So I also create a mapping that maps event code from the Linux kernel to the constants I declared here. And on each message, I create a new access event that I'm mapping using this mapping from event code. So I get the access type and I'm setting the access value as the raw value. Sorry, the event value as raw value. Now for parsing, I noticed that the range of values that's being sent from the wheel is in the range of 0 to this number. I think it's 16-bit. And my racing wheel specifically supports 900 degrees of rotation. So I map that raw value into degrees. So when it's all the way to the left, it's 0 degrees. When it's all the way to the right, it's 900 degrees. And for the brake, clutch, and accelerate pedals, I noticed that when they are not pressed, the resting position value is 255. And when they are fully pressed, it becomes 0. So I did some basic inversion here. So it's the invert when it's not pressed, it's 0. When it's all the way pressed, it's 255. So we do that. And what I did next was I created I wanted to do all of this in a separate Go routine because for this project, as I said before, we are going to also send messages to a different process running on this host machine. So I want this input handling stuff, parsing, all of that be handled in a separate Go routine, while my main Go routine can take care of sending messages to different processes. In this case, to the NeoVim process to control it. So I create a new channel that accepts bytes because I'm gonna just send byte messages. I don't need anything extra. I'm just creating this byte channel. I'm passing it to listen to events. And these handle button message and handle axis message functions return a byte. And I grab that byte, and after handling all of that, I send that byte to the channel. Then in the main Go routine, I get that byte, and right now I'm printing. But for the next stream, we are going to create a Unix domain socket messaging between my Go process and the NeoVim process. And we are also going to write a Lua script that starts listening to messages from this Go process and does something. For first, what I'm going to do is when I rotate the wheel to the right, I'm going to grab the character under the cursor, increase its ASCII code, and insert it instead of the current character under the cursor. So when I'm moving my racing wheel to the right, I go forward in the alphabet. When I move it to the left, I go backward. So in that way, I can have some sort of inputs in my text editor, and we're gonna figure out the rest of the buttons, rest of the mappings afterwards. That was it. I'm just gonna go look at the recording, see what was okay, what was not. If you have any suggestions, what I need to do. I wanted to keep this stream short because this is my first time streaming and I don't know anything about Twitch. I usually just watch Twitch through clips or already edited videos on YouTube. So I don't know how to interact with the chat. I don't know about any of the settings. So I'm just gonna go watch the recording, see if my voice was fine, if the recording is okay, stuff like that. And I'm gonna probably create a schedule for my future streams so we can go over this project. And when the project is done, I am planning to edit this whole streaming process into a short, well, relatively short, 20 to 30 minute YouTube video where I'm just gonna build this project from the ground up. So that's it. Stay tuned. If there are any of you listening, there are 3 of you, which is nice. So yeah, that's it. I'm gonna stop streaming now.